Welcome back to AI Edge Daily, the channel where we break down the most cutting-edge developments in artificial intelligence. I'm your host, and today we're diving into a breakthrough that could fundamentally change how we interact with large language models. Google researchers have just introduced something called faithful uncertainty, and it's poised to solve one of the most frustrating problems in AI today: hallucinations. If you've spent any time working with large language models, you know the struggle. You ask ChatGPT a question, and it confidently gives you an answer that sounds absolutely plausible. It's articulate, it's well-structured, but it's completely made up. That's a hallucination, and it's been one of the biggest pain points for anyone trying to use these models in production environments. Doctors don't want their AI giving confident wrong diagnoses. Lawyers don't want their legal research tools inventing case law. Researchers don't want their literature reviews citing papers that don't exist. So what exactly is faithful uncertainty, and why should you care about it? At its core, this is about making language models honest about what they don't know. Instead of forcing a model to generate an answer when it's uncertain, faithful uncertainty allows these systems to express genuine doubt. But here's the crucial part. It's not just saying, "I don't know." It's about providing what Google's researchers are calling best guesses, essentially allowing the model to say something like, "I'm not certain about this, but here's what I think might be true, and here's why I'm uncertain." Think about how humans actually work. When you ask a person something they're not entirely sure about, they don't just make something up. They might say, "Well, I think it could be this, but I'm not confident." Or they might give you multiple possibilities and explain which ones they're more or less sure about. That's exactly what faithful uncertainty enables large language models to do. The research comes from Google's AI research division, and it addresses a fundamental challenge in how large language models are trained and deployed. Current models are trained to generate text that continues a given prompt in the most likely way based on patterns in their training data. But that training process doesn't inherently teach models to distinguish between things they know with high confidence and things they're just guessing at. It's all output as equally confident statements. What makes Google's approach particularly interesting is how they're implementing it. They're not just adding a confidence score to model outputs. Instead, they're working with the underlying probability distributions that language models generate. When a language model produces text, it's actually calculating probabilities for what the next word should be. These models can look at those probability distributions and determine when they're relatively certain about something versus when the probabilities are spread out across many possibilities. Faithful uncertainty allows models to leverage that information more directly. When the model encounters a question where the probability distribution is uncertain, it can express that explicitly rather than arbitrarily choosing one of the possible continuations. It's a more honest representation of the model's actual state of knowledge. Let me give you a practical example of why this matters. Imagine you're using an AI system to research historical events. You ask it about a specific battle from the Napoleonic Wars. With a traditional model, it might confidently tell you a story that sounds historically plausible but contains invented details. With faithful uncertainty, the model might say something like, "The general outline of this battle is based on historical records, but some specific details about troop movements are less certain because the historical record is incomplete." That kind of nuance is incredibly valuable. Now, implementing this across the industry isn't automatic. Google's researchers have developed specific techniques, but integrating these into existing large language models and training pipelines requires careful work. The approach needs to be implemented during or after training, and it requires models to maintain access to their probability distributions during inference. That's computationally feasible, but it's not quite as simple as flipping a switch on every existing model. What's particularly exciting is that this research opens up possibilities for other improvements. If we can make models express uncertainty about individual facts or statements, that creates opportunities for follow-up mechanisms. A user could ask, "Why are you uncertain about this?" and the model could point to specific reasons. Or systems could use this uncertainty information to trigger fact-checking mechanisms, asking humans or other tools to verify claims where the model lacks confidence. The implicat.